figured out and differentiated between the redshift, the proportionality, we can move on to finding the change in redshift and the velocity. So to find that, we have to figure out our speed of light, which is differentiated in c, and also the change in the wavelength of an object, because we said earlier that with a redshift, there's always a wavelength, and how it's moving towards us or moving further than us. And then we also have to get by to the original wavelength. Usually, the object that is moving away from us emits light. Let's pretend that maybe it's a photon or a particle that is emitting, basically a particle that is emitting light. So here is what the equation would be for the velocity. C, which is for light years, change in the wavelength, and then over the original wavelength. The original wavelength is usually 656.3 nanometers, which is less than a centimeter, due to the fact that when the hydrogen atoms come from the third level to the second level of the atomic configuration. So that is the hydrogen alpha line, and this is how to calculate the velocity of an object moving away from us. So this would be something like this. What actually happens is light takes time and a proper distance to reach us. So do you know how when we look at the sun, it's just what we saw 8 minutes ago? It will be the same thing when an object moves far away from us. When an object moves far away from us, it's basically actually in another area, but we see it here. Therefore, we minus the 656.3 from the perspective's vision. And therefore, we figure out the change in the wavelength. So V equals to C, change in the wavelength over the original wavelength. And that's how we would measure the velocity. Remember that hydrogen's alpha line is 656.3 nanometers. That is the velocity being set. Now, how would I also calculate the Hubble if I found my velocity? If I found my velocity, I can calculate the Hubble by saying, because now that we've figured out the relationship, I can calculate my Hubble by saying velocity over distance. And there you have it. A very simple calculation, but really, it kind of takes time to differentiate between the velocity of a moving object and how the Hubble sends information. By the way, the Hubble didn't really directly send information to the astronomers. They had to figure out different calculations themselves. And of course, there were some errors. And obviously, over the course of time, the Hubble constant wasn't really constant in history, but it should be accurate so we can find the proper distances and proper velocities. In a later video, I will show you how to find the distance between different galaxies. Thank you, and remember to join in for the IAC competition this year. The deadline is by the 15th of May. Thank you.